T was an honored second when the Andromeda cloud, for the present, transformed into the Andromeda world for a seriously prolonged stretch of time. How we could decipher the Andromeda framework was limited to ground-based discernments at any rate. Yet, with progressions in development and the presentation of the James Webb Space Telescope, our appreciation has created past measure. Now, things are going to change, as the James Webb Space Telescope has recognized upsetting signs coming from the Andromeda universe. These signs have sent shock waves through laid-out specialists, leaving cosmologists both energized and curious. Yet what exactly do these signs mean? Specifically, for what reason are they causing such a blend among cosmologists? Go along with us, as only 2 minutes earlier, the James Webb Telescope shut down after getting upsetting signs from the Andromeda universe. Before we could see a long far beyond our eyes into the universe, cosmologists confided in the smooth technique for being the sum of the universe. This absence of information was essential because of confined advancement for seeing various universes and individual stars. Anyway, everything changed when we found the Andromeda framework. It filled in as our most significant piece of information that the universe stretches out a long way beyond the smooth way in human imagination. Everything began in the 17th century when Galileo Galilei's pioneering work with telescopes uncovered the smooth way's genuine pith. He saw that the smooth way had different stars, testing the general idea of its lone importance. Everything changed during the 1920s when Edwin Hubble found faraway items past the smooth way, utilizing the Hubble Space Telescope. Edwin saw that these brilliant items going through the universe were worlds not equivalent to the smooth way. One of the worlds was the Andromeda world, or M31. While this was the first time we were seeing the Andromeda universe through a telescope, Persian stargazer Abd al-Rahman al-Sufi first noted it around the 10th century. Scientists trust that to have a predominant comprehension of our universe and the smooth way, we ought to concentrate on the association between Andromeda and the smooth way. This is especially genuine given that the two universes are prone to crash in around 4 billion years. While studies and assessments have progressed, the James Webb Telescope as of late got an upsetting sign from Andromeda. This upsetting sign befuddles analysts overall, inciting inquiries regarding its exact beginning and potential ramifications. The James Webb Telescope's high-level sensors have identified unusual development right inside and around Andromeda's center. The signs sent back to scientists show results that contrast essentially from past perceptions, interesting specialists around the world. The sign uncovers major processes happening inside the cosmic system, possibly connected to its gigantic dark opening or beforehand inconspicuous occasions. Clearly, one of the latest disclosures shows that Andromeda's mass may be a lot more prominent than that of the smooth way, reshaping our comprehension of the two system sizes. The James Webb Telescope has given detailed pictures and spectra of Andromeda, uncovering the course of action of new stars and their substance creations. This new data is critical for understanding vast advancement and likely circumstances for life. Moreover, the information from the telescope proposes expanded action in Andromeda's dynamic, inestimable center. This has eventually impacted its encompassing climate and is expected to shape its future construction. Besides, by exploring the gravitational impacts on stars inside Andromeda, experts gain insights into the dispersion of strange dark matter all through the system. Hopefully, this propels how we might interpret its effect on the elements at play in the universe, as understanding dark matter and its impact on the universe remains one of space science's most prominent mysteries. Late leap forwards by the James Webb Telescope have prodded further examinations all over the planet. As analysts investigate the secrets of Andromeda, with more becoming exposed, we presently find out about the universe's past and future. So, what have we found about the Andromeda cosmic system through different examinations? Andromeda has shown astounding characteristics that recognize it from different cosmic systems across the universe. Its sheer size commands consideration, with ongoing evaluations proposing a measurement of around 220,000 light-years. This makes it one of the biggest cosmic systems in the close-by bunch, indeed, even larger than the smooth way, involving an expected trillion stars, outperforming our system in heavenly count. Experts also find the system's structure entrancing. Dissimilar to an ordinary twisting universe, Andromeda has a protruding focus and a thick center encompassed by rings of residue and gas. This is, without a doubt, a productive ground for continuous star arrangement. Such elements show a unique cosmic system shaped by relentless cycles among its numerous qualities. One of specific interest is its center, set apart by a double-top discharge, demonstrating the presence of an exceptionally huge dark opening. Yet, unique from the smooth way, the Andromeda system is likewise encircled by a radiance of stars, planetary and globular bunches, broadening a huge number of light-years in width. This tremendous envelope recounts an enamoring story of the system's one-of-a-kind development and history. The 460 globular bunches found in Andromeda also offer insights into the arrangement of stars in the universe's initial stages, providing a clearer comprehension of the plan of star bunches and the cosmic system's initial development. By disentangling the secrets of Andromeda, cosmologists are one bit nearer to getting a handle on the stupendous meaning of dark matter. Anyway, one inquiry remains. How do they represent its perplexing nature and the job it plays in the elements of worlds? Andromeda gloats another particular element: its satellite cosmic systems. Its core design involves more than 20 more modest worlds, some of which are being deprived of their stars and gas by the bigger system. This cycle involves a larger system pulling in and obliterating adjoining more modest universes, exhibiting the powerful idea of cosmic development and showing how worlds develop and interface over time. So, what does the future hold for the Andromeda world? The shape and direction of its advancement charms space experts as well as those looking to figure out the universe. The potential for its change from a twisting to a curved system is to some extent significant in Andromeda's improvement. Proof focuses to a communication that could lead to other interesting consolidations, maybe from infinite impacts or close experiences with different worlds. If Andromeda really is moving toward this path, it proposes that it has gone through various connections with different systems since its development. Eventually, Andromeda's future relies on the inescapable impact with the smooth way. According to models, this impact is supposed to happen in around 4 billion years. The consequence of such an effect would be the development of another system from these two monstrous, enormous elements. Albeit the impact would be disastrous, it is a normal piece of enormous advancement. Anyway, because of the tremendous distances between the universes, this vast impact isn't an imminent occasion. After the effect, the two universes would be generally reshaped, making new designs and arrangements. The converging of their gases and residue would work up another pattern of star development, prompting a fantastic show above as the combining objects shine brightly. This galactic occasion would bring about the formation of a solitary curved world. Such effects are not remarkable, as the universe has a long history of such occasions, yet our direct inclusion makes it a huge occasion for us. Also, the expected crash of the very monstrous dark openings at the focuses of the two cosmic systems adds further interest to this vast display. This proposes a complex and significant nature of gigantic development. The consolidation is supposed to deliver blasts from the matter being consumed by the dark openings, bringing about extraordinary radiation. This cycle provides significant data about how universes advance throughout their life expectancies and how dark openings impact this development. Anyway, it brings up an essential issue. What will happen to our planetary group after this consolidation is finished? Nowhere near an altogether annihilation of the nearby planetary framework, the close-by planetary framework's direction and conditions could be modified altogether. This suggests conceivable orbital moves or even discharges from the newly framed system. To figure out this component, specialists can concentrate on the size of comparable occasions and contextualize the inescapable destiny of our own nearby planet group. It is vital to grasp that impacts between stars are uncommon in space due to the enormous intergalactic distances. How, anyway, gravitational changes could upset stars' stable circles, causing a few stars, including our Sun, to change course. Such a change could fundamentally influence Earth's environment, possibly prompting either warming or cooling impacts. A hotter environment could cause ice covers to dissolve and ocean levels to ascend, while a cooler one could set off another ice age. Furthermore, such a shift could hinder radiation levels arriving at Earth, making significantly more difficult circumstances. The converging of the Andromeda and smooth wave frameworks highlights the multifaceted connection between heavenly bodies, as the dark openings in the two cosmic systems come closer over time. Their gravitational cooperations might increase the animosity of high-energy particles that could arrive at Earth. This likely expansion in radiation levels could represent a danger to Earth's biological systems, possibly leading to expanded transformation rates in populations and influencing biodiversity. The inevitable arrangement of Earth's circle or hub, coming about because of the dark opening consolidation, could affect how biological systems are dispersed. How living creatures will adjust to ecological zones that might turn cold is one of the effects of environmental change experienced around the world through shifts in biodiversity and environmental structures. Albeit some species could flourish under the new conditions, others could become wiped out or face extreme dangers. The difference between Andromeda and our world can be used to foster more exact models for vast elements and development. The reassessment of Andromeda's size and mass is projected to add another layer of information that empowers the investigation of the progression of the universe's grand scale. The James Webb Space Telescope's capacity to observe and identify forms of interest gives extraordinary advantage in this venture. Its results may advance science, helping to arrive at wider conclusions regarding dark matter and its impact on the universe. Along these lines, the observance of Andromeda goes beyond mere astronomy. It is a door to grasping the profound and dynamic universe we are part of.